This is a demonstration video where an old AC unit has been modified into a split AC unit. So for this project we're going to use some specialist tools. This is a HVAC gauge set, probably the most important tool in a HVAC tool belt. We're also going to use a HVAC recovery machine because we need to recover the refrigerant from our old AC window, recover it, and then reuse it when we do the modification. And finally, some other tools. We're going to use a rather nifty tube bender for HVAC. And also, as the window AC unit doesn't have access valves, we need to add those. So we have some access valves and a piercing unit. So this is the window AC unit that we're going to modify. It's a standard 110 volt window AC unit, 12,000 BTUs, and runs on refrigerant R410A. So here is our window AC unit with the outer cover removed. We can see in the evaporator at the front, we can see a lot of dirt. Originally there was a filter in the front of this. Either this unit was run without the filter for a period of time, the filter was ineffective, or the preventative maintenance was not carried out for filter replacements. But we can see a lot of dirt on the front, so this is really not good news, and this will have to be cleaned. So air would have gone in, and then this is the ductwork which returned it back into the room. So let's have a look. Let's take this cowling off. We can see inside the machine. So there are a couple of fans. Looks like the fans are connected by a single shaft. So there's one motor that drives this. So originally, this window AC unit, it effectively would have been split in half. Half the unit would have been outside. The other half would have been inside the room. So this fan would have circulated the air around the inside of the room. This is a radial fan, so this sucked air through the center, pulling it through the evaporator heat exchanger. So room air would have gone in, it would have been cooled, potentially below the dew point, which could have resulted in condensation. There is a drain hole, difficult to see, but at the bottom of the cowling there's a hole which would have ducted any water which would have accumulated outside of the building, obviously not to keep the inside of the room dry. So this fan would have pulled air in, circulated it up. There is some ductwork which ducted it, and then it would have returned into the room through the front. The other fan, attached to the same motor, would have circulated air around the outside of the outside of the AC unit through the condenser. Effectively cool down the refrigerant, which is circulated around by the compressor. The compressor is this unit here. Talking about it. So the compressor's function is to recirculate the refrigerant. This particular unit has about a pound of R410A refrigerant. So the compressor compresses that refrigerant, it exits through a high pressure side and then travels down and enters the condenser, which is a heat exchanger outside the building, which it effectively would have taken this hot refrigerant due to the compression and cooled it to ideally the same temperature as the outside air of the building. Then it returns from this condenser through some pipework, through an expansion valve, which I assume is tucked away under here, into the evaporator. The refrigerant then cools the heat exchanger, which then cools the air which is circulating through the heat exchanger to cause the air conditioning effect inside the room. So this particular unit's got a control system, nice basic one. So there's the control panel. Looks like here there's like an IR sensor, so it must have been fitted with a remote control. There appears to be a thermocouple on the front of the system for measuring the room temperature of the air going in. Maybe also to measure the temperature of the heat exchanger to avoid freezing. And there's a control system, very simple, little control transformer, starting capacitor, probably for the compressor motor. Two relays, these are the blue units. These relays are contactors, would have electrical switches, probably one for the compressor and one for the blower motor. So some AC units have got Schneider valves for charging, maintenance purposes. This unit is obviously built for very low maintenance. So this is the suction side. So when this was filled, there was a pipe which was brazed on. You can see the braze joint there. This pipe then would have gone to the test dials filling system when this unit was manufactured. After filling, this pipe is then crimped. It's crimped in two places. One crimp here, one crimp there to seal it. And as a final safety measure, there's a blob of solder or braze, which is at the outside of this joint to hermetically seal the line or line set. And then there's another one on the high pressure side, again crimped two places, and a blob of solder. So we're going to have to use some special attachments to extract the refrigerant from this system, as we're going to reuse it and put it back into the AC unit once we've done the split. So there's a couple of interesting points on here as well. We can see some insulation. Not quite sure what this 2.5 inch section served. Maybe it was like a vibration thing with the outer casing. We have some other insulation which is split, the cable tie. I don't think this would have been particularly effective. Another one down here. We've actually got the electric cable running inside the insulation, again split, held together with two cable ties. A little bit peculiar. So yeah, we're gonna give this a go and take it to the next stage. The next step is to extract the refrigerant from the AC unit. As the line set is sealed without access valves, we're going to perform a hot tap into the line set with these piercing valve adapters that we're going to attach to the copper tubes.
So we're going to recover our refrigerant from our compressor, our line set, in this window-based AC unit. So we've got to connect it. There's a pierce valve there we need to actuate. That's connected to a couple of gauges so we can monitor and control what's going on. These gauges are connected to a recovery machine, which is going to pump the refrigerant out of our window AC unit and into our tank where we're going to recover our refrigerant. Okay, so I'm now going to pierce into the line set using our adapter, and we should see a pressure on this gauge. Here we go. First time I've done this. Okay, we'll wind out a little bit. Yep, there we go. See the pressure rising. What have we got on there? So, okay, the room temperature I'm in at the moment, which is about 100 degrees Fahrenheit. I've got close to 20 atmospheres of pressure on this line now. So I'm now going to put this through our HVAC recovery machine into our bottle for storage. Okay, so this cylinder is under vacuum. I'm now going to open this valve and transfer some of this into our HVAC recovery machine and do a very slight bleed on here to ensure that this line set is purged of all air before I start recovering the refrigerant into the cylinder. So I'm going to slacken this off. I'm going to open this a little bit. Okay, so I'm going to open my bottle now, and the vacuum. I'm going to open this, I'm going to transfer it to the other side. Okay, now it's pumping from my line set from my window HC unit through a recovery machine into this bottle. And we can monitor the pressures on the inlet side and the outlet side. I think it's fair I can increase the rate. Now we wait. I'm going to open this a little bit more. No, that's it. So just a test to see if refrigerant is still being released. If I close this valve, yeah, you can see the pressure increasing as refrigerant is coming out into our gauge set. Let's open it up again and continue the transfer. And now with a negative pressure on the inlet. Let's have a look at our gauges. Okay, let's close our inlet. And the pressure is not rising. So I'm going to close the tank. I'm going to close the inlet. The inlet's already closed. To see if this pressure rises in the morning, if there's anything worth in addition to recover. We'll close the outlet, go into our recovery machine. I'll turn the recovery machine off. So I'll turn that close, and off. Silence. And that's it. We'll see what our inlet gauge is in the morning. If we got anything, then we'll continue the recovery. If not, then we'll go to the next step and split the unit. Okay, so the refrigerant out of the system. Let's take this clamp off and see if we can split the unit to get our evaporator and our condenser separate. So this did the job. Oh, see a small little piercing there. So let's take this.
This part of the video is sped up to save everyone some time. Effectively, I'm breaking the unit down, taking out the evaporator, separating it from the condenser. So you can see me using a tube cutter, pipe cutter, to cut the line set. Now disconnecting the control panel, marking wires, just in case I need to reuse them. And now hopefully I can remove the evaporator. Yep. So there's a lip in front which is preventing me from removing the lower cowling and the radial fan. So a little bit of modification, and yep, we've got that off. So to modify the condenser, a new cover was made. Let's see if it fits. Now we'll mark the bottom and we'll cut the excess off to make it tidy. And this will go on the outside of the building. So we split our window AC unit a little bit more. So here's the condenser, the original motor, it's the original capacitor that I've wired up to this fan. I've not connected the compressor yet until I complete my line set. I don't want that running dry. Here's the evaporator coil that's been separated. This is the electric motor that we picked up from the scrapyard. So I've made a little coupling to go between that and the radial blower. I've bought a capacitor for this. So we're separating this unit completely from the condenser. So let's switch on the power to the condenser. And sure enough, that fan blows. So that should do the cooling outside of the house. And then let's switch on the radial blower. And yep, sure enough, stuff is doing some blowing. So hopefully we should be good. So this should be cycling through the evaporator, blowing out and returning through the cowling back into the garage. Excellent. Now we install the line set. First off, we drill a hole.
That's a big hole.
Now we push the line set through the hole where we're going to connect to our AC unit.
On the outside of the building, the line set is pushed through a 2-inch PVC pipe. This is a standard drain pipe. This is a lot more cost effective than a traditional outside ductwork for an AC unit. Some of the AC tools make life really easy on installation. For example, this AC tube bender. This bends the tube really neatly without any risk of kinking the tube. Makes doing a 90-degree bend easy peasy. And now we're going to braze the line set together. To do this, we're using a copper, phosphorus, silver alloy as the braze metal. The advantage of this is that we're not going to use any flux. Flux could potentially introduce contamination into our line set. In this case, the phosphorus is basically acting as the flux. We also have a purge of inert nitrogen gas flowing through the line set. This prevents oxidation on the inside of the copper tube. So to install the condensate drain, we're going to mark out where the hole needs to be using a Sharpie. Now we're going to remove the radial fan and the lower cowling using a drill. We're going to drill a hole. Now with the hole drilled, we're going to test fit our drain line, and we're going to apply some silicone sealant to seal around our drain line on the top where it's going to meet with the cowling. And we're also going to put a blob of silicone sealant to help secure the cowling in a constant position within the frame that we've built. And now we're going to install the radial blower. Now we're going to install the bolt which holds the radial blower fan onto the shaft and onto the motor that we harvested from the scrapyard. Now we install the evaporator. Back into the system. Okay, so I think we've brazed all our fittings correctly. So now we're going to pressure test the system. So I've got my high pressure hose connected to the high pressure side of the line set. I've got
On my gauge set, I've got a high pressure nitrogen supply on this port, so I'm going to open it up and pressurize my system. So I've pressurized it to about 300 psi or 20 bar, and now I'm going to check the fittings. Not the tiniest braze joints in the world, but the easiest way to check is to get some soap solution and apply it over the braze joints. Definitely over this fitting. And we'll wait 5 minutes and we'll look for bubbles. And if we find bubbles, then we need to rework the joint. One little trick is after you've applied the soap solution, which can be dish soap, is make sure you wash it down with water afterwards to prevent any corrosion, as dish soap can be quite corrosive. So after applying the dish soap, we didn't see any bubbles in any of our fittings. We've had the system under pressure, all the valves have been isolated, and we've maintained that pressure for 6 hours. All the joints have been checked with bubble solution, and no bubbles have been detected, so that's encouraging. So we haven't got any gross leaks. So what I'm going to do now is depressurize the system and put in the Schneider valves. So I'm going to discharge it through this port. Okay, so this is the port where the Schneider valve goes in. Unscrew this cap. See, the cap's got an O-ring on there, the sealing. Obviously the valve was removed from brazing, so it's got an elastomer on the seal, so we're going to pop him in there. Using the end of the cap, which is quite a nice design, rotate that in. So with our service valves connected, I'm now going to pressurize the entire system with 300 psi of inert nitrogen gas, and I'm going to leave it for 12 hours and see if it maintains pressure. Let's connect up our test gauges. So do the high pressure first. Screw him in. Yep, 20 bar. And we're going to try the low pressure one as well. And screwing him in now. So we maintained a pressure of 300 psi or around 20 bar in the high pressure side, low pressure side, which is all connected. So the system integrity is good. So we're now going to release the nitrogen gas that we're containing within our line set. So to do this, we undo a fitting and release. So now connect our vacuum pump and evacuate the line set to remove any air, nitrogen, moisture from the line set. And begin the process of evacuating the line set. Okay, so we evacuated it. So the high pressure side is connected, so I'm going to turn the vacuum system off and I'm going to allow refrigerant into the high pressure side. Now we use the refrigerant recovery machine to transfer all the recovered refrigerant back into the new system.
So the refrigerant back in the system, I think we're now good to switch it on. Turn on both fans and the compressor. Okay, so compressor's running now. See the suction side has gone down in pressure. It's gone up a bit, so okay, this thing should be working. And sure enough, with the compressor running, both fans on, we have a cold breeze now in the garage. There was some icing on the evaporator coil. This can be a typical sign of a low refrigerant charge. And of course, since we added a line set between the condenser and the evaporator that is larger than the original line set of the window AC unit, we need to add some additional refrigerant to the system. There are many better videos on the internet with information on how you can calculate if you need to add refrigerant based on temperatures and pressures of the system. Okay, so it's been running for about 20 minutes now, and we'll have to put that drain on for the condensation. To be honest, I wish I put a slightly bigger pipe on there now. This obviously has to be ducted somewhere. Right now it's just dripping into a bucket. But it seems to be running. So, can you turn a window AC unit into a split AC unit? Absolutely. Is it worth doing? Probably not. It's a lot of work to make the housing for the evaporator, and in the near future I've got to tidy this up, I've got to add a filter, I've still got to add a control system, so there's still a lot of work to do to really tidy this system. Having said that, I've used the system for one summer now and it's performed flawlessly. To be fair though, I've only run it for maybe around 200 hours, as the garage is not occupied very often, but it does work.
And as always, please subscribe and thanks for watching.